So, yes, now I'm requesting Damisha ma'am to kindly start this webinar session, please. Thank you.
Good afternoon to all of you, and welcome to this next talk in this series of webinars we are holding as a part of the Azadi ka Amrit Mahotsav, which is being celebrated throughout the country. This is to commemorate 75 years of independence and a glorious history of the people, culture, and the achievements of India. This event is dedicated to the people of India who have been instrumental in bringing India to this level and also continue to contribute towards India as a global economic power. To boost this movement, there have been a lot of activities which have been taken all over the country because it is a mass movement. We have exhibitions, we have seminars, we have talks, we have awareness campaigns. And we in Skill Council have decided to host a series of webinars, talks, interact with the speakers, learned people in various sectors which we are promoting, in the sectors of waste, in the sectors of renewable energy, water management, sustainability, and all other areas related to environment sustainability. So we have done about 79 seminars, and I think today is the 80th one. And in this, we have had a lot of interaction and speakers from across all sectors. And in fact, a lot of learning has been there. And we have compiled all this in the form of a YouTube series, and all the lectures are available. It is a wealth of knowledge which we really cherish. So today, we have a very learned speaker. He has a lot of experience in, I would say, in the electrical engineering side. And he is touching on a topic which is a lot of activities happening both in the government sector and in the private sector. The government has come up with the green hydrogen policy where there's a lot of focus, where they want to promote manufacturing, and not only manufacturing, they also want to focus on the distribution, on the storage, on the production, because all these things are equally important. If we will produce, then we have to distribute, we have to store, and then we have to use it. That is how that is for green hydrogen. So in Skill Council also, keeping in mind the trend or the push by the government, we have developed training modules for the manufacturing side, and we are doing more in this sector. So with this, I would like to invite Mr. Kiran Kumar Alla, and learn and hear from him more about this green hydrogen, how we can make better sense, what is the economics behind it, what makes it a good candidate for our energy transition. Welcome once again, Mr. Alla, and thank you very much for accepting our invitation of joining us in this webinar. Thank you very much. And I'll request Mr. PB Singh to kindly introduce you.
Thank you, ma'am. Thank you very much for welcoming the speaker and all the audience. Good afternoon, everyone. I'll welcome you all to the 81 series of the webinar. Skill Council for Green Job is organizing a series of webinars to celebrate Azadi ka Amrit Mahotsav as a part of India's celebration of 75 years of independence. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, and waste management, as so deepen the understanding of recent development in these sectors. The first in the series was launched on 24th September 2021. Today we have Mr. Kiran Kumar Alla, a very experienced learner, distinguished speaker who will be sharing his expertise and experience on making sense of green hydrogen. I would like to share his brief profile with all of you. Mr. Kiran Kumar Alla is an electrical engineer with an MBA in finance and marketing from Indian School of Business. Mr. Kiran Kumar started his career as a shop floor maintenance engineer for 7 years, then shifted to HR consulting with focus on learning and development for 5 years. He then went to ISB for his MBA and moved back to electricity sector, 5 years business development in power transmission sector, followed by another 5 years with Delhi electricity distribution utility in various roles, including as head of Central Engineering Service and Renewable. He then joined Bloom Energy, a leading players in the stationary fuel cell space. At Bloom, he worked on Indian business development, product management, and business development in the marine sector. Mr. Kiran Kumar, currently working as a senior director in Plug and leading market development at Plug. He is actively working on further green hydrogen adoption in various sectors. Now I'm requesting Mr. Kiran Kumar to start the presentation. Over to you, Mr. Kumar.
Yeah, thank you, Dr. Praveen and Mr. PB Singh and Skill Council for Green Jobs for giving me this opportunity. Let me quickly share my screen. Okay, hope you can see the screen.
Yes, it is visible.
Wonderful. Yeah, as I said, when I got this request to speak on green hydrogen, I could have talked on many things, but I thought it is very important to understand why do we really need this hydrogen or green hydrogen for that matter. So it's very important, I thought, to make sense of this green hydrogen. What is its role? Why is it important, right? What is its role, etc. So I thought that, so this presentation is from that perspective. A high level agenda. I'll talk a little bit about our company so that you know where I'm coming from. Then I'll go into why hydrogen, green hydrogen production, what is the cost reduction, and some scenario in India. So about Plug Power. Plug is a US-based company or a 25-year-old company. Plug has been working in the hydrogen fuel cell systems now for the last 25 years. The most successful hydrogen-based fuel cell application that Plug developed is fuel cells for forklift trucks. So you can see in this corner. So where we replaced the lead-acid batteries with hydrogen fuel cells, and customers have adopted this solution like anything. So we have more than 60,000 fuel cells operating on hydrogen right now. Every day we do about 50,000 hydrogen refueling activities and consume about 50 tons of hydrogen. So that is where we started our hydrogen journey. And because customers are valuing green hydrogen, company decided to move into hydrogen production as well. So in order to produce hydrogen, you need electrolyzers. So the company acquired various companies and technologies in the required space. So now we have a solution, electrolyzer solution, a PEM electrolyzer solution. We have hydrogen liquefaction solution, hydrogen storage solution. We are in the process of setting up green hydrogen production network in United States of America and also with partners in Europe. We also have these hydrogen fueling stations. Currently, these fueling stations are not public fueling stations. They are inside the customer warehouses. So the customers use them for their own requirements to fuel the forklift trucks. Similarly, in Europe, we have a joint venture with Renault. So they are already developed a light commercial vehicle. So it will be used as a passenger bus, mini bus, and a last mile delivery van. By the end of this year, we expect to see a lot of those vehicles on road. In addition to that, we are doing various experiments or various collaborations with various applications. And one of the applications is even in aviation. If you have recently come across a aeroplane using hydrogen fuel cell, Universal, I think was the company. So that fuel cell has been supplied by Plug to that company. So, and lastly, the most emerging market now is the stationary fuel cells for backup. So for backup, we currently use DG sets. So the grid could be very green, but when power fails, you still use DG sets and causes local pollution. And we are seeing a lot of demand for this product. And also in where there is a grid constraint, where you cannot get sufficient power. So we saw customers getting interested to use hydrogen fuel cells and produce electricity locally. In some cases, we have even seen customers wanting to use this fuel cell generated electricity to charge electric vehicles. So a lot of people generally think, oh, batteries are and fuel cells are competing, but actually, if you see, they are all complementary in a way. So that's something very, very important we need to keep in mind, that all technologies will be required for decarbonization. It is not one single solution. So that is something I would like to start with. Just a little bit of disclaimer. Many of these slides are not my creation. So I mean, just the ugly ones are mine. I'm not a great slide designer, but I have certain opinions. Many of those may not be my companies. There's nothing confidential in this. This is all public info. You can use these links and go back and do your own research and make sense. And the sector is continuously evolving. As a person, I would like to be an optimist. If you have any point, yeah, you can argue at your own risk. You can ask questions anytime and type in the chat box. And finally, you should do your own research after hearing to what I say. Okay, so with that, let's jump in. Okay, so why hydrogen? So hydrogen is nothing new. Hydrogen has, I mean, people talked about hydrogen economy in 1960s, 1980s. Even 10 years back, people said, oh, hydrogen is going to happen. But we know that it has not happened. That is factual, right? But now things seem to be slightly different, because now earlier it was like very few discussions, but now you can see now multiple sectors, multiple companies, multiple geographies talking about hydrogen. And the key reason for hydrogen's time, I think, is coming not so much from anything else, but because of our focus on decarbonization. So now the question is, okay, how does how do we make sense of hydrogen? If it is new, if it failed earlier, why will it succeed now? That's a big question all of us would have. So if you think about it, hydrogen is nothing new. Hydrogen is already being used by industry across the globe. This is 2017 data. If you update it, this 830 million tons is now would have grown to about 1,000 million tons of emissions from the hydrogen sector. So about 100 million tons equivalent to 1,000 million tons of CO2 emissions is the emission from the hydrogen sector right now. If you see from emission geographies, after China, US, India, Russia, and Japan, hydrogen is actually in the 6th place if you think about it as a country. So any decarbonization of this global hydrogen right now is a great opportunity to decarbonize the whole earth, right? So as a sector, it offers a unique opportunity to achieve a large chunk of our decarbonization target by switching over to a new technology. Now, what is the technology? Let's look at it in the next slide. I'm sure you would have come across these various colors of hydrogen. There are more colors, more than what I have on this slide. I just picked up the simplest ones. So where the source is coal or lignite, it's either called most brown coal, brown hydrogen, and the most common one, rather 95% of the current hydrogen comes from natural gas. So which is what is called gray hydrogen. And it uses a technology called steam methane reformation. And the carbon intensity, at least for the benchmark level, everyone uses a 10 kgs of CO2 per kg of hydrogen. So as you can see, we are doing if you are doing 100 million tons of hydrogen, so it's equivalent to 1,000 million tons of CO2. So now as we go down, the next technology that everyone is also talking is blue hydrogen. So basically the same process of gray, but actually doing carbon capture and usage or sequestration. So the idea is some of the carbon is captured, so the hydrogen will be low carbon hydrogen is the thinking. And the last, I think, and the most promising for us, at least in India, is the green hydrogen, which can use either biomass or biogas or water as a feedstock and electricity in combination using electrolysis converts water into hydrogen. So that is where the emissions can actually go down closer to zero, may not be exactly zero because there are many processes, but actually this is the lowest in carbon intensity hydrogen. Now, this is good. So this actually, the previous slide and this gives us a sense that if we decarbonize gray hydrogen into green hydrogen, it offers a great opportunity, right? But I will now present something slightly different here. So if you think about how we consume energy, right? So on the left-hand side, it shows the share of different sources in 1990 and the same thing in say 2019 or 2020. if you see, not much seem to have changed. So direct heat is still very limited. In fact, it has shrunk. Electricity has kind of slightly grown, right? From less than 20 to more than 20. Biofuels and waste seem to have slightly shrunk. So natural gas seem to have slightly grown. Oil products maybe might have slightly shrunk. Coal again looks slightly shrunk here. But the important thing to understand is, I mean, I come from the electricity sector. So at least 5 years back, I used to think that, oh, if we convert all our coal plants and everything into solar and wind, we'll be able to decarbonize energy sector in a big way. But after I moved to the fuel cells, natural gas and hydrogen space, I realized that electricity is actually supplying only about 20%, not more than that. And rest of the energy is coming from other sources, particularly if you see coal, oil and natural gas. So this whole energy supply, if it needs to be decarbonized, we need an alternate solution. So electricity could grow, but then what will happen to the rest of it? So we can't just focus only on decarbonizing electricity, but we also have to look at other possibilities to decarbonize the energy sector. So this is again the same thing in a slightly different perspective. You can see here, this is this slide that in 2009, we were at like 17% electricity share, and in 2020, like 19, maybe we are at 20 right now. And it is expected, if you leave it as it is, it will grow to like maximum 26% by 2050. So that means 74% will be from non-electricity sources. So that's a very important thing. And even if we successfully decarbonize electricity, the 74% will still remain not decarbonized. Even if there is biomass share, so the rest of the 50% will still remain decarbonized. So that's a huge challenge that needs to be addressed. So that is where I think hydrogen's role becomes very, very important. Now, what is the value of hydrogen? So if you think about it, so the value of hydrogen, I try to see purely from a marketing perspective, right? What is the value? So one, as hydrogen adoption increases, unlike some products, the value of hydrogen keeps increasing, because as the availability of hydrogen increases, the adoption increases, and if we crack transmission, it'll further increase hydrogen. So the value of hydrogen continuously keep increase. So it's a very good feature in hydrogen. Second, currently, certain set of people feel that hydrogen will not solve a lot of problems, and there is certain set of people feel that, oh, hydrogen can do so many things. But I will be somewhere in the middle, more pragmatic. But the real value is somewhere in the middle. So that is something we will start seeing as we start adopting more and more of hydrogen. And lastly, we are in the early stage of hydrogen. So there is a lot of discussion, but there is no adoption. Now, this discussion, as it converts into adoption, we will definitely see a very high value rapidly emerging. And this period could be from current now to 2030 and then to 2050, after which it will become part of the system. And then I think it will give us the benefit. And what is the other value of hydrogen? See, one obviously is decarbonize. Second, it actually allows us to store energy, not just in the electricity form, but also in a molecular form, not just electron, but also molecule. So you can actually store for a longer duration and all those kind of things. And it actually helps us create a resilient energy system. So grid, as we know, whenever there is a cyclone or any natural calamity, the first thing that gets hit is grid supply. So therefore, we need some kind of alternate energy system that will help us continue to run the activities. So hydrogen has a lot of value from a resilience perspective as well. So if we see some of the impacts that hydrogen has, it actually gives us a hope that yes, maybe we can decarbonize Earth, so we can actually believe in our future. It actually reduces anxiety, because if you look at the pollution and other things, we generally get anxious that when will this change? And will definitely promote wellness. It reduces risk, and ultimately it will avoid actually a lot of hassles that are there with say things like carbon capture, for example. There are a lot of hassles. We'll put it inside the ground. We don't know what will happen. If it comes back, what will we do? So there are some questions. With green hydrogen, I think that issue is not there. So now, another important perspective to think about is, see, both fossil fuels and renewables and green hydrogen. So the fossil fuels, you can equate it to something like hunting, where the energy was readily available. All you had to go and get it. But in renewables and green hydrogen, it is more like farming. Here you have to do a lot of work, not one step of work. Here you have to actually do the land work, then you have to do the sowing, then you have to ensure that it grows, then you have to cut it, and then you have to store, distribute, and all that. So similarly, the energy value chains, fossil fuels value chain right now is fairly simple. You have to find out where it is available, extract it, and refine it and supply it. But in renewables, there is one additional step that is coming. We have to produce the energy, and we have to use that energy also to produce the green hydrogen. So it will be definitely challenging in the initial phase. But I think as we master, just like we mastered farming, as we mastered this renewables and green hydrogen, I think we will find that this is far more beneficial than simply using the readily available resources. So we'll have better control is what my perspective is. I mean, there are some other perspective. One of the important things that I feel green hydrogen offers is infinite supply, in the sense that as long as you can scale solar and wind till we reach the maximums of solar and wind, you have the possibility of converting that to hydrogen. So that's a major advantage. And obviously, as we discussed, no carbon footprint. And it actually has higher energy density than other forms of energy. It can actually be transported in large volumes. And then you can actually convert it into electricity and you can store it for long duration. When it comes to long duration, we know that batteries are a very good source of energy storage. However, it is limited by the duration that we can utilize, and second, the quantum that we can store in the batteries. Here it shows about hourly duration. Maybe you can stretch it to a daily storage, but beyond that, batteries get limited by the capital expenditure and also the turnaround kind of thing. So the number of cycles used batteries, the better they are. There are other technologies like compressed air. Now, recently we have started seeing some interest in pump storage. It is a difficult one, but there are opportunities, and wherever there are opportunities, we should use pump storage. And then comes green hydrogen, which actually has much more long duration storage possibility of yearly, and also a large scale of storage of more than like terawatts of storage that is possible. So that's one of the main advantages of hydrogen. Now, so it's again going back to the point that the different energy sources that we use, the electricity and non-electricity sources. So how would these two kind of help us and then solve the decarbonization trouble? You can think from this perspective. So this is a Department of Energy, United States graphic. So where it shows that electricity grid infrastructure, right? It actually has generation, storage, various things, and ultimately the load that it serves. Similarly, hydrogen is parallelly working. It actually takes some electricity to produce hydrogen, but it can be used in various applications like vehicles, fuels, ammonia, refining, heating, and all, and also produce electricity. So they both can actually work in a very complementary manner and decarbonize the whole energy sector. The same thing, if you see in a slightly different way, you have power grid and you have gas grid. So there are even opportunities like methanation or using hydrogen directly, but you can see that the renewable energy sources, fuel cells, right? They can actually provide two parallel opportunities to decarbonize. So they actually will work very complementarily is the main idea behind this. Now, in terms of, broadly the sectors where hydrogen will find use, you can see that without converting hydrogen, you can actually directly use in many sectors. And with transformation as either as synthetic fuels or as green ammonia, you can you put it in pipeline, you can store it and use in certain sectors. So, I mean, this is all an evolving sector. There are some use cases where, as I said, we already have 100 billion tons of hydrogen already being used in the industry. That obviously can be done without any transformation. But rest of it, we have to figure out whether to use hydrogen directly or to use it after converting it to some kind of synthetic fuel or into the green ammonia kind of perspective. Now, this is one of the projections. So right now in 21, it was like close to 100 billion tons. Right now, the estimates are at like 100 billion tons in 2023. And the estimated growth is like 175, 180 million tons by 2030. This is one estimate by IEA. Similarly, another estimate of Deloitte, this report just came like in the last week. So they see that by 2030, we will reach 172 million tons of demand from green hydrogen space. And you can see the sectors where this demand is going to come from. So you can see that majority of demand is coming from industry, iron and steel, other industry, and then comes transport, and then comes power and a little bit in the building space. So as you can see, building space is very limited. So that means it is going into the bulk sectors rather than into the retail sector. So that is what the expectation generally is. Now, this is another matrix to understand that you can see the sectors, industry like steel, ammonia, methanol, refining, chemical, cement, and other industry. So here there are various applications. And as you can directly see, the potential to decarbonize wherever there is H written, that is very high. So you can see steel, ammonia, methanol, refining, it is very high. It can be done before 2030, and it will keep growing till 2040. So here, hydrogen is already being used. So therefore, that is an advantage. So therefore, all you have to do is change the source. You don't need to do anything else. There is no need to figure out how to transport, how to store, because that is already being done currently. Similarly, you can see that fuel in heavy duty long haul transport. So here, there is a decarbonization dimension and also favorable economics in comparison to, say, battery or other alternatives available. Shipping is another sector. I have seen personally that there is a lot of interest and demand either to use hydrogen or methanol. In fact, I think the last 1 week there was a methanol powered ship that has been already launched by the world's largest container ship company called Maersk. So they already committed themselves to methanol. That ship has already been launched. See, and there are many other ships in order. Similarly, ammonia is being explored by other companies as well. So, however, the technology is kind of in the initial stages and maturity has to grow. And once it grows, it kind of starts growing quickly. Another sector which has committed itself to decarbonize is the aviation sector. So, aviation sector is currently in the process of adopting sustainable aviation fuel. Hydrogen can play some role in that. And also, hydrogen can also be directly used. As I mentioned earlier, one of our partner companies has done a trial using fuel cells that are powered by hydrogen. Cars, as you can see, the decarbonization opportunity is very less, more electrification and more economic to do battery based. I think because the utilization is very low. So that is the reason you see that the projection is very limited in cars. Similarly, in trains also, electrification is more easy than converting to fuel cells. So there will be some limited adoption where there are challenges. So residential and commercial, again, very limited adoption. So therefore, you can see that industry is where maximum hydrogen adoption is going to happen. So this is another slide to indicate that, okay, you can see that transport has a potential to go even up to 50% adoption. Industry has an adoption possibility up to 30-35%. The rest will come from electricity. Buildings will have limited. Again, in a total energy share, you can see that the possibility of hydrogen can go up to 20%, between 10% to 20%, right? So even at a 15% energy share for hydrogen, the hydrogen electrolyzer demand is estimated like 3,000 gigawatt. And right now the installed capacity might be like, maybe 1 to 2 gigawatt is my estimate. But definitely in the single digit gigawatt at this point, if you combine all the electrolyzers in the world. So that is the kind of growth possible in this sector. Now, another perspective to think about is, what is the willingness to pay? Everyone talks about $1 per kg of hydrogen cost, but $1 per hydrogen kg is a long-term target, not an immediate target. So different sectors have different willingness to pay due to different reasons. For example, the forklift trucks application is an application Plug has pioneered, and where we have seen the customer gets a lot of benefit. Customer gets a lot of benefit in terms of high level of productivity throughout the day. That means even if there is no discharge of battery and therefore lower output. Similarly, there is no space required for chargers. There is no additional forklift trucks required, which will be in charging, right? And also, I have learned that batteries performance goes down dramatically if they are operated in very low temperature conditions, not only high temperature, but also very low temperatures. So fuel cells have a better performance in that. So therefore, a lot of these material handling applications, converting forklift trucks to hydrogen has been seeing huge amount of traction. Both in US, we have seen this, it is continuing to grow. Similarly, it is continuing to grow in Europe. And we definitely expect that segment to grow even in India. Now, to kind of summarize, So what is a positive spiral for hydrogen? So the first thing is to achieve scale. So industry shift to green hydrogen. So there will lead to cost reduction. This will lead to wider and global supply chain, and we will gain a lot of experience and expertise. And finally, we will be able to achieve standardization. So this is one major wheel that will help us reduce the cost. So once the cost comes down, the next step is about hydrogen transportation in a pipeline. So once we figure out pipeline-based transportation, we will be able to access lower cost. That means the transportation cost will be insignificant. It will be widely available, not just in main industrial areas, but also in many cities. Then you can actually co-locate hydrogen production along with renewable energy sources and at the sea. So there will be no water-related concern. There will be no transmission losses, and you can combine multiple RE resources and convert that to hydrogen. And pipeline also acts as a storage, right? So even if there is interruption or change in production levels, pipeline actually provides that resiliency that currently we can see the same benefit in fossil fuels. So natural gas pipelines, for example, act as storage. Similarly, in coal, even the coal lying in the yard is storage in a way. So if there is a lot of rain and all, you still have coal available, right? Similarly, hydrogen in the pipeline will be available even if there is some supply disruption for a duration. And if you have long duration storage connected, then you can actually have energy security as well, even in a situation of any geopolitical or climatic situations. And finally, this will help in adoption by transportation sector, especially shipping, long distance, trucking, aviation and all will adopt this much more because now it is available at all locations. And finally, it becomes a sustainable energy fuel, sustainable not only from emissions, but also as an energy carrier. So now it becomes a mainstream energy carrier. It will be complementary to electricity and it will fill in for grid. So if there is excess electricity in grid, which is leading to negative electricity prices, it can absorb that electricity and convert it to hydrogen. And when there is high demand, it actually convert back to electricity and support the grid. And once hydrogen is widely available, as we have seen in battery sector, we will see many applications that we don't even have an idea right now to convert into hydrogen based applications. And finally, it will become an enabling energy resource for overall humanity, growth of humanity and economic development. So I think this is what is one of the most, this is what I think is going to happen. Obviously, there will be many challenges, not that it will be a smooth walk. There are many technological challenges that need to be cracked. But I think I see a path going forward in this direction. Now, green hydrogen, broadly, there are three technologies. There is biomass based, but I'm not talking about it. I'm talking about only the electrolyzer based. So there is alkaline electrolyzer. So the alkaline electrolyzer has been in use from a long time. Similarly, PEM electrolyzer. PEM electrolyzer also has been there from a long time, but only at a very small scale. Similarly, third, we have solid oxide electrolyzer. Solid oxide electrolyzer technology has also been there for some time, but it was mostly used in the fuel cell side, not as electrolyzer. So now we started seeing those electrolyzers as well. So now alkaline electrolyzer uses KOH solution as electrolyte. So there is liquid in it. It generally operates at low current density and at atmospheric pressure. So there are some pressurized alkaline technologies also coming. But again, it uses a liquid electrolyte that makes it a much bigger footprint compared to PEM electrolyzer. PEM, on the other hand, uses a solid electrolyte, and therefore it is very compact. It doesn't use any liquid electrolyte. You give input only water and electricity, and output you get hydrogen and oxygen. Solid oxide, again, is a slightly different variation. Solid oxide uses steam in place of water. So you have an advantage of utilizing waste heat and reduce the electricity required. So some electricity based input is being supplemented by water. So that makes it the operating cost of solid oxide lower than say PEM or alkaline. However, solid oxide currently is very expensive. At least I heard numbers in the range of at least 3 times compared to PEM, even much more in comparison to alkaline. So this is a alkaline stack. So this, as you can see, is a huge stack. And if you see, this is a PEM stack. This is a 1 megawatt stack. As you can see, it's just like close to one person standing and handling it. So that is a footprint difference between alkaline versus PEM. Solid oxide, again, I don't have an electrolyzer stack, but this is roughly how it looks like. This is Bloom Energy, my previous employer's pictures. So this is a cell. This cell is put together to create a stack, and stack you put it in a module and make it bigger. So these are the three different technologies currently kind of at least available. Alkaline is already available. PEM is also available commercially. Solid oxide trials are happening. Some traction we are seeing. The fourth one is anion exchange electrolyzer. Anion exchange is roughly a combination of alkaline plus PEM, or trying to get both the good things from alkaline and PEM together. But again, I think it is at least a couple of years away from commercialization. Is what my sense is. Okay, so broadly, if you think about this electrolyzers, so this is from a research. This is a couple of years old, but it will give you a sense. So alkaline, the stack is like 50% of the total cost. PEM, on the other hand, the stack is the most expensive, but because the system is very solid, the other costs are lower. On the other hand, solid oxide, the stack is again lower cost, but the power electronics is very high, and the balance of plant actually is very, very high. So because it uses thermal energy, it needs a lot of balance of plant. Anion exchange, again, I see that the stack is cheaper, but the balance of plant becomes expensive. And you can see in the below right-hand side corner table that the alkaline price ranges are anywhere between $540 to $900 per kilowatt. PEM is between $667 to $1450. This depends on the company's maturity. Companies which are already ahead and achieved scale, so their prices are on the lower side, but the new companies, their prices on the higher side. And solid oxide, as you can see, the lower side is also actually very high, almost 4 times or plus, and the higher side is obviously very high. AEM, you don't have any exact numbers because commercially they are not totally kind of fully available. So in terms of the electrolyzer cost reduction opportunities, there are multiple dimensions that can happen. Obviously, currently, because the energy cost is high, energy consumption per kg of hydrogen, if it is reduced, it will reduce it will actually help reduce the cost of total hydrogen. It doesn't reduce electrolyzer cost, but actually a higher cost can be absorbed if it is more efficient. Stack lifetime, if it increases, it will reduce the electrolyzer total cost. Similarly, module and stack size, if you start increasing, the bigger the size, the cost per kilowatt will go down. The operating range is the input operating range. That means whether the stack can operate at, say, 30% of input, or can it go up to, say, 100% or above 100%. The higher the operating range, the better it is in terms of the total cost of hydrogen. Similarly, electrolyzers, PEM electrolyzer, for example, everyone talks about the concern about using precious metals. So those materials, there is a continuous effort to reduce the use of scarce material. So that is leading to the reduction in cost of PEM. The startup time is a very important thing, because when you start up the electrolyzer, the initial phase, I have noticed that the hydrogen purity may not be up to the mark. So therefore, you have to vent a lot of hydrogen before you start using the hydrogen. So startup time is very important. That will increase the production. And when you are combining it with renewable, so this feature becomes very, very important. The scale of production, like manufacturing of electrolyzers, is currently a small industry. It is growing. Plug has set up a gigawatt factory last year. So now we already reached the full production level of more than 100 megawatt per month. So more and more factories getting set up and the scale increasing will mean the cost of electrolyzer goes down. The last one is the average stack cost. So as I said, this is a combination of many things, including what materials are used, what is the size, what is the scale. So that ultimately leads to this reduction. So this is the cost reduction dimension for electrolyzers. So let's go to the other parts of the green hydrogen cost reduction. Now, say hydrogen production cost using natural gas, because this is the benchmark price right now, because all the gray hydrogen is produced using natural gas. Last year, natural gas prices increased dramatically. During that time, none of these these numbers would have made sense. They were all almost like 5 times these numbers. So a number here in United States, $1 became almost like $5 at that point, short time. May not be in US so much, but I think Europe had seen a lot of high prices. So a $2, close to $2 would have reached even $10 or more. Even in India, we have seen that gas prices even hit $40 per MMBTU. So So I think we are close proxy to us is about China, right? So our prices of gray hydrogen are close to $2. So it would have hit like $8-9. So, but now again natural gas prices have settled down. So this can be a good proxy. But as you can see, when you try to use carbon capture, the carbon capture price increases by at least by roughly about 50% where the price is low, but where the price is high, at least by $1 in this kind of markets. So this is the hope that if carbon capture works, the blue hydrogen could provide interim solution while the green hydrogen costs actually come down. Now, if you see, this is the levelized cost of hydrogen production by energy source. So natural gas currently is in the $1 to $2 range. And the expectation that with carbon capture, it will be like $2+. With using coal, the estimate is it like almost close to between $2 to $3. Coal with carbon capture will kind of slightly increase, not significantly. With solar right now, it is in the range of anywhere between $3 to almost $8, depending on the cost. But going forward, the expectation is that green hydrogen cost will come down to about 1.2 to 3.2 kind of range. So this is the expectation. So in the interim, when the green hydrogen costs are coming down from this place to this place, so maybe blue hydrogen will provide a little bit of respite to the energy prices. If you see this slide, in some cases, green hydrogen is already viable in some cases, right? Where the cost of solar is low, and then you have right kind of applications, green hydrogen actually starts making sense even now. So that is the reason we are seeing a lot of projects happening, but not to the extent of all the announcements are moving forward, because there is a certain amount of cost reduction required. So depending on the cost of electricity, we can see that the curves show that the cost can come down from $7 to even close to like $2.4. And at this level, it can actually, by 2030, a lot of different PVs will come into the competitive range. And by 2050, we can see that almost all solar PV based hydrogen generation will be cheaper than the current prices. So this is one of the projections. Another way to think about is the more and more electrolyzers get deployed, so the cost will start coming down from the above 600 to the range of $200 to $100. This is the ultimate goal. So I talked about 3,000 gigawatt. So that is somewhere here. So when we actually do 3,000 gigawatt installation, so we will reach this much lower cost of electrolyzers. Lastly, I mean, just think about what is the impact of renewable energy and what is the impact of electrolyzer. So electrolyzer cost of $1,000, but at the $65 per megawatt hour is $5 per kg. But electrolyzer will help you actually bring it down. If electrolyzer cost goes down by 30-40%, it will bring down by about $0.50. So same thing goes forward. But if the renewable energy goes down from $65 to $20, you can see that $5 will become $3 straight away. So the biggest lever is in renewable energy. And as deployment happens, as we have seen in this previous slide, electrolyzer, more deployment means more cost reduction. So the idea is that we should start deploying and then focus both on renewable energy cost reduction and electrolyzer cost reduction. I'll quickly run through global scenarios in next 5-10 minutes so that we have some time for the Q&A. So hydrogen strategies published or under development. This is now, 2022 looks like 1 year old now. But as you can see, almost all over the world, there is some kind of hydrogen strategy published and or under development. Now, if you see, this is like different directions the renewable hydrogen or green hydrogen is taking shape. United States is giving a direct incentive of up to $3 per kg of hydrogen. And there are tax credits for carbon capture and there is tax credit for storage, right? There is also subsidy and support for developing hydrogen hubs in United States. India, we all know that about $2.4 billion has been allocated under the National Hydrogen Mission. This includes hydrogen production, electrolyzer manufacturing, R&D, and even pilot projects. Recently, for green steel production, Ministry of Steel has got allocation of about, I think, $50 to $60 million. They want to do some pilots. So they will come into this pilot project space. Similarly, we have already a green hydrogen transmission charges waiver, and there is also a renewables banking facility that is available. I think we have taken a slightly different approach compared to United States. Similarly, Europe has a multi-fold approach because of multiple countries involved. So they have set up a European Hydrogen Bank. They have a hydrogen procurement. This H2 Global the idea is to procure from other countries and import green hydrogen, right? And they also have this emission trading system, carbon tax, and they also introduced a carbon border adjustment mechanism so that imports into Europe will not be at a high carbon intensity. If a product is high carbon, they'll have to pay fees. So that means it will make sense to produce in Europe at low carbon intensity. Similarly, Japan and Korea are looking to do their own hydrogen production, but also import hydrogen in a big manner. So China, we all know, is doing a lot of stuff. Australia is focused more as an export market. So this is another way to look at what is happening across the world. In India, I think these are the forces that is making green hydrogen a very important resource for us. We don't have a lot of domestic gas, and the cost of imports is very high. So we spend anywhere between $100 to $120 billion every year to import oil and gas. So therefore, it makes sense to supplement that with green hydrogen. Second, we have abundant solar and wind resources. So this is something we naturally have. And the benefit of solar and wind is, even if some supply chain disruption happens, solar and wind is within the country. So no one will be able to stop that solar and wind. So we can take benefit of that. And we have a large domestic market that can help in reducing and reaching lower costs. And we also have an ambition to be a hydrogen export hub. The renewable energy companies in India, they already done a lot of work, and they are looking at export as an opportunity to enter into global markets. Similarly, our energy companies, they have been exporting refined oil. For them also, they are looking at hydrogen as another way to export energy. So this makes hydrogen a very attractive sector for India, very huge growth driver for India. So India, as I said, we have high potential. We have very high country level alignment for green hydrogen. And we have seen interest from all players, not one sector. Oil and gas, renewable energy, EPC, everyone wants to be in hydrogen. As I said, the export ambition is a key driver. So we have a lot of demand already, 6 million tons last year, and we expect it to grow to 12 million. So we have set a target of about 5 million tons per annum. And this translates to about 60 to 100 gigawatt of electrolyzer requirements. So these are some sectors where demand is expected: fertilizer, refining, steel, and methanol. This is expected demand. And as I said, I talked about the policy already. There are some financial incentives that were mentioned in the draft. I hope some of them will come out and we'll start seeing them happen. This is the interstate transmission charges waiver policy that I mentioned. So you feed in the renewable and wind at the remote locations, and you withdraw here on site, and you have a banking of 30 days, and you can have high electrolyzer utilization, and you can utilize on site for various applications. So this, I feel, can provide a possibility of $2 to $3.5 per kg of hydrogen cost in the coming time. Lastly, this was a recent assessment by USAID SAREP. So they estimated that even at a business as usual, there is like $23.3 billion investment opportunity, about 1.1 million metric tons per year. But the base case is looking at minimum of 2.8 million metric tons, which means 62 gigawatts of additional renewable energy capacity, 29 gigawatts of electrolyzer, and at least 14 million tons of ammonia. So in all cases, as you can see, the ambition is 5 million tons, right? But even at the minimum of the minimum, we are looking at a large scale growth, right? So that's the most important thing. And this slide broadly provides the number of companies that are involved in the hydrogen thing. Everyone is interested in this area. You have electrolyzer manufacturers, we have hydrogen producers, we have oil and gas companies that are interested. So a lot of activities happening in this space. I thought I can take a pause here. I thought that because this is a skill development council for green jobs, I could find this resource which talked about hydrogen and fuel cells career maps in different levels. So there is an entry map, there is a mid level, there is an advanced. Right now, as you can see, there is a lot of advanced also opportunities in the operations and management. But in terms of research and all, there are entry and mid level of opportunities emerging. and a little bit of communication, training, and outreach related opportunities as well. I can open this slide, but I think I'll leave this link with you guys so that you can explore and understand the job descriptions and use it to kind of collaborate with other agencies and develop courses in these areas in India. I think with this, I think I would like to take a pause here and see if there are any questions.
Thank you very much, Mr. Alla. Yeah, this last slide is very, it will be a real use to us because we are also developing training modules at various levels. And I think this will be very helpful. The whole presentation was very illustrative. And I could say that, as you said, hydrogen has always figured, during the past few years, hydrogen was always there, but it did not get the type of importance or focus which it has been given now. I remember Spic Science Foundation, we did a 25 kilowatt solid polymer, this fuel cell. Then VHL R&D also, we had one phosphoric acid, but those time the companies were not there. The companies, the private sector was not in the focus. Electrolyzer was never a focus, but with the green hydrogen production coming, electrolyzer has become the focus. I would like to pick up the chat box. I think Mr. Srinivas, Mr. Rohit, could you give the rights to Mr. Srinivas? He had asked a question. I'm not able to find that. Yeah.
No, thank you. Mr. Kiran, I think it's an excellent presentation. It responded to many of the queries in our minds. As a professional of many other renewables, we did have, at least I did have a lot of questions, but you clarified many of them. But when I wrote in the chat box, but one part of the question was kind of covered in your later presentations. I'm a person in hurry, so I wrote that question, I think, on the cost. So you have done that. But if you want to respond quickly, that's one. But another thing I wanted to ask you is, on the gasification, green hydrogen, what is the route that Globe is taking? Whether extraction of H2 from producer gas or produce electricity and then use it for the electrolysis? So that's one question.
Okay, sure. I will answer that question. The most important thing I think we have to remember why green hydrogen figures out in almost every scenario is the scalability of green hydrogen and the challenge of carbon capture, right? At a certain point, for example, when solar and wind has become cheaper than coal, right? Everyone is saying, oh, why coal when solar and wind is cheaper? Same thing is going to happen with green hydrogen. When green hydrogen becomes cheaper, then people will say, why are you extracting carbon and complicating it, right? So initially there will be blue and green and any other colors, right? Particularly US policy doesn't differentiate between blue and green. It simply says carbon intensity. But in India, unfortunately, we don't have too much of oil and gas resources. So we should, I would definitely think that we will use oil directly and focus more on green hydrogen. So it depends on the country's resources and all. So in general, I see Europe particularly moving more towards green hydrogen. Okay, maybe simplification is where the country is an energy importer, they will focus on green hydrogen. Where the country is an exporter, they will focus on blue and green. That is a trend I'm seeing.
Thank you.
Yeah, thank you. I think, Mr. Rohit, can you give the rights to Dr. Raman? Dr. Raman has also asked, and then Neha has also put a very long question.
Yes. I already gave rights through everyone, ma'am.
Yeah, Mr. Dr. Raman, are you there?
Can you hear me?
Yes.
Yes. Good morning to everyone. It is a very good presentation. Just my question is like this. You told that there is a logic, at least 3 times costlier that solid oxide electrolysis compared to PEM. I also want to know that how does it impact on the efficiency part, a comparison between these two things, basically the kilowatt hour per kg of hydrogen kind of.
Yeah, absolutely. I think solid oxide obviously uses about 20% lower electricity because some of the energy is getting supplemented from the heat, right? But there are 2 questions there. One, how long will it take to recover the additional capex that we invest from the operational efficiency? That is the payback period perspective. Second concern is, as the electricity cost going down significantly, the efficiency benefit value also keeps going down. But there are some industries where waste heat will always be available. So therefore, there are some places where solid oxide will definitely have an advantage over PEM and alkaline. But But the advantage of the cost will make it kind of that difference will always remain, and then that will make it solid oxide. Again, this is my opinion, restricted to certain applications where waste heat is readily available. Right. So that is how I would.
What about the material cost?
I mean, yeah. So
that will also. Yeah.
Exactly. Solid oxide is a heavy technology.
Yeah.
So, I mean, I worked in solid oxide, so I can say that. So therefore, in some applications, it'd be fantastic where there is waste heat available. But in some places, I think PEM or alkaline, depending on the space and renewable energy combination, those factors will come into picture. Not just efficiency and cost, but other factors also will become important.
Okay, thank you very much. Because as ma'am was asked rightly the question, because it can even that OPEX also comes here when you purchase the materials actually.
Absolutely.
Anyway, this thing has to be looked into, because one side we are looking for a lower cost actually, that approaching that $1 per kg, and if the capex goes up, it may have some impact. That's what my question.
Exactly.
Thank you very much. Thank you.
Thank you.
Yeah. So can you give the rights to Neha Saka? Neha, are you there? Oh,
yes, I'm there. Am I audible?
Yes.
Yeah.
Yes.
Okay, sir, your presentation is really very insightful, and thank you so much, Kiran sir, for providing us with all this knowledge. I have a couple of questions. So basically, my confusion is regarding the implementation. For
Right.
example, that we have discussed about the renewable energy based plant for generation of green hydrogen. Now, when we talk about RE based plant, there are three ways in which we can implement it. We can either go for off-grid, on-grid, or hybrid.
Yeah.
In off-grid and on hybrid, we would have I would say, a challenge to have battery storage system. Battery energy storage system would be required. Would that be replaced by fuel cells themselves, in your opinion? Because having battery energy system is again a very great challenge because of all the issues.
Sure. I saw
Another
the
question
question.
is,
Yeah, please. If there is anything other than what you've written, if you can elaborate. Otherwise, I'll answer the question on the chat.
okay, yeah, there's another thing that I wanted to ask, that in fuel cells that we have seen certain materials that may be scarce or may not be scarce. So is that?
Yeah, go ahead, please. Okay, so let me try to answer this. See, the decision what mode to use will totally depend on economics right now. All three that you mentioned are possible. Let me tell you that fuel cells and batteries act in a very complementary manner. So fuel cells continuously can produce, whereas batteries can absorb ups and downs. So there is a complementarity in them. So the optimality depends on the use case, load curve, and the cost of fuel cell versus battery and hydrogen. So we will see a combination of all of this. Current scenario, the phase one between 2023 and say 2027, I will not go to 2030. We will see mostly on-grid solutions. That means the electrolyzers will be connected to grid. People will take advantage of banking, right? I don't know whether batteries will be used or not, because since you are connected to grid, you will get the benefit of continuous supply. But I think as we move forward, as renewable energy increases in share, you will start seeing that prices of grid power will go down significantly during daytime. We have seen negative prices in Europe, right? So in those kind of scenarios, combining these electrolyzers with renewable energy will come. So that will be like maybe partially off-grid, partially on-grid. But I think hybrid is what we will see. But what kind of hybrid is something we cannot define right now. So it'll the percentage of battery or the percentage of grid or off-grid, this will keep on evolving. So someone asked about how safe would this technology be? What are the possibilities? Yeah, along with mini grid for solar plants. See, safety, obviously, just like any other fuel, safety is a concern. And hydrogen is all the more because one, you can't see the flame, it is colorless. But on the positive side, hydrogen escapes into atmosphere, it doesn't stay in one place. So it doesn't lead to explosions. But at the same time, you need to be more careful because we don't have experience. So you need to have sensors, you need to have methodologies and standards to be followed. That is very, very, very much required. As I mentioned earlier, we do more than 50,000 refuelings every day. So they are happening, and the operator is doing it. So it's not a specialized person doing it. Operator is fueling his own hydrogen tank, right? So that means safety is manageable as long as we follow the right standards, right procedures, and right equipment. Okay, another part of the question is, are we self-sufficient to produce or dependent on other countries? I mean, I'll be very honest here. I like the Atmanirbhar Bharat slogan, but I like the Bharat Pe Nirbhar much more, right? See, we have to keep in mind that the global trade is the only reason the whole globe is growing, right? So while self-sufficiency is important, energy security is important, but we have to take advantage of our strengths and also take advantage of strengths of other countries. So the technology transfers, product transfers will keep happening, right? We should not be unduly concerned about importing, right? Unless the other country is going to untwist us. So we need to develop a diversity. We need to do the tie-ups so that we bring the technology, we can produce here. So Plug, for example, has 150 people working in India for global market. So the knowledge base is here, right? So all those things are happening. Different companies are following different things. So I would say it will be a global trade in hydrogen, not just every country becoming an independent island.
Yes.
So Dr. Vanita Prasad has asked this question. Apart from material cost, question of availability of materials required to make hydrolyzers in India. So this is, I feel, I mean, see, obviously, when we are not, for example, lithium has been a scarce resource. Suddenly there was a news, oh, we find a lot of lithium resource in a couple of places. Again, the next day there was another news saying that, no, that is not real, kind of also. So my sense is that currently we don't have this material. They come from specific geographies, and every country in the world is this time, because of experience of COVID and the war, every
चल रहा है भाई हाँ नहीं अभी तो ऐसे बाहर चल रहा हूँ बस
He's
I'm muted.
muted.
Yeah.
Yeah. Please carry on. Yeah.
Yeah. So what I'm saying is, so every country is trying to have a minerals and materials for decarbonization strategy. I think that is an important thing that India should also take up. Initially, we will be importing stacks. I am also seeing there is also a possibility of imports from China, right? There is also imports from Europe or US. Both will happen, and there is a lot of work that we can do in India. And as we gain experience, I think we'll do more and more indigenization. And even the precious metal requirement in PEM technology, a lot of people, media overplays it, but I see that it is becoming less and less concerned as research is happening. The grams of, say, platinum or iridium required per megawatt is going down on a daily basis. So these are happening. So R&D scientists they are busy on this. We are only discussing, they are actually working on it.
Yeah. So Dr. Prasad, you have any other question? Dr. Vanita Prasad, can you hear me?
But she's on mute, I think.
Yeah, please unmute yourself.
Yeah, no, not in the talk, because he was talking more on that side. But since you are saying that researchers are working, we are also working on the other ways which
Right.
are linear and not using this technology. So I'm working on biohydrogen. So
Yeah.
where we can use anaerobic fermentation to do hydrogen.
Oh, yes. See, the bio-based, bio-root hydrogen is another important interest, right? So I think even our definition of green hydrogen will include biomass related, is what I was told. So, I mean, the idea is we have to decarbonize.
Yes.
And we have to use all the resources that we have available, right? Some technologies will have certain advantage. So, but we have to look at a portfolio approach rather than saying only one approach.
Yeah. So biohydrogen is one of the option, but still internationally it is on TRL 3 yet. So we don't see the future for this side. But yeah, we signed on this side, and we find it that it will be using lesser of the resources which are available. Maybe not at all, because we are working only with the waste material which we are generating as such.
Correct.
That's
One comment on that is, one thing when I was in this solid oxide technology, biogas could have been used directly by solid oxide fuel cells, right? So when I tried to research into that space, one block I always hit was the supply chain of biomass. So that needs to evolve. I think once it becomes available, I think it becomes easy to take benefit of that supply chain as well.
Yeah, that's where the CBG will evolve in India. Simultaneously, this hydrogen can evolve because the supply chain will be there. And that's where Praveen ma'am and sir is working a lot.
Absolutely.
Supply chain. So that needs to be stabilized, and we will have some route on that.
Absolutely.
Yeah,
Okay.
most of the problems have been there because of the supply chain. You know, the plants have shut down. In fact, I feel, I should say, we will evolve from horse to hydrogen. As we keep removing carbon, we will be, we will reduce more. I said we'll go for decarbonization. So
Right.
the evolution is from horse. We started with the horse. Now we will go to hydrogen. So I think if there are no more questions, there is one question from Mr. Rahul Mitra. If you could read it. Yeah.
Yeah, I can read it.
Deepak
Yeah.
Rai. Deepak
And
Rai.
two questions. In fact, Mr. Deepak Rai is also there. Yeah.
Hello, Rahul here.
Yeah.
Yes, Rahul.
Hello,
Yes. Yes.
I am a trans man. My community is trans. I belong to transgender community. We have a meeting in Delhi where some Mr. Sharma from SCG, he was told about the green job. So I want to know if we want to take it as a job or business. So the possibilities of the income and the future of the transgender person, can you highlight on this, and how can I contact with yours get facility to for skill training or job or business?
So maybe Dr. Praveen, you can give the contact details of.
I think we have started some, that is why the link is there. We have started some trainings for this category of people also. And the types of trainings that I will have to find out. So if you can send us a mail on this.
Maybe you can type it in the chat.
Yeah, in the chat box.
Yeah, while you type that, I will go to.
Yeah.
Okay, I will share my mail ID. Means our organization mail ID.
Yeah, I will. Rohit, can you put my email ID? Yeah, I'm putting mine also. You can send a mail to me, and we will work on this, because there is a connect now with this category of people for training and skilling and training. So what are the job roles that I have to find out.
Right.
Yeah.
So I'll go to I assume that Deepak's is the last question.
Yeah, I think so. Yeah.
Yeah. So here, the question is, where do we stand in the global race for generating low-cost green hydrogen? Is the industry waiting for PLI tenders under the mission? There are many investment announcements, but financial closure are not being done. See, it's the most important thing is the offtake, right? Unless there is an offtake, lenders will not come forward, right? If it is a small project, that's a different, it can be done on a balance sheet. But if it is a large project, it has to be on a project finance kind of mode, where the lenders would like to see where the revenue stream is going to be from. So there are broadly, obviously, there are two directions. One is export, second is domestic demand. So originally, the Green Hydrogen Mission had a mandate for refining and fertilizer and also gas blending. The draft had that. But when it was finalized, the mandates have been removed, but there is a mention that the mandates are being on discussion and they might be announced later on. So when mandates come, the industry will automatically try to procure either the equipment or hydrogen, one of that. That will lead to domestic demand getting kicked off. When there is a demand, automatically financial closures will happen. So that is one side of the story. The other side of the story is export-based demand. And as I mentioned earlier, Germany is one country which has started trying to procure from global markets. So there is this agency called, I think, H2 Global. So they are trying to procure from various countries. They have floated requests for response, RFPs and all. But again, they have not advanced yet. But that is already they have got funding from their governments. So those projects will go forward, subject to we being commercially viable or being able to compete with other players. If you think about it, the main component of hydrogen cost is renewable energy. We have achieved 2.5, 2.6, 2.7 kind of numbers. But the challenge with solar will be that it is available for only 20% of the time. So therefore, you need to figure out a methodology of round-the-clock renewable energy, either take benefit of some of the banking, take benefit of diversity between solar and wind. So if there is a project that gets set up at a port using solar plus wind and a little bit of banking, that might be competitive in the international market. But I know that there are some other agreements signed with Singapore-based company, and I understand that they have proceeded. They are in the advanced stages of financial closure. So things are developing. Once the PLI-based tenders happen, that will further we will be able to see who are the players who are serious, who will participate in the tenders. So then we will also see more action. So I think that is what is happening right now. That's my understanding. Thank you.
Yeah, thank you. I think there are no more questions.
Yeah.
Thank you very much. And I think we have to wait and watch and see how we progress, but we will certainly progress. That is an optimistic note on which I would like to conclude. And I think thank Mr. Alla. It was a very good presentation. You connected all the loops and you told us how we can look at green hydrogen for the future. So I once again thank you, and thank you for connecting with us and giving this time. And of course, a very beautiful presentation. Thank you very much. I request Mr. PB Singh to kindly extend a formal thanks. Thank you.
Thank you, ma'am. I would like thanks Kiran Kumar for the excellent presentation, and you explain very well and answer the very deeply to the audience. Thank you very much, sir. Thank you very much. And my special thanks please convey to Arpo also, who is introducing. Thank you, sir. Thank you very much. Yes. And I would like to thank all the audience who are attended the presentation and provide his valuable times. Thank you all. Thank you very much. Thank you, Kiranji. Thank you.
So there's a lot of thanks in the chat box also.
I appreciate it.
Yeah.
Thanks for the opportunity.
Yeah, thank you very much. Have a good day. Yes.
Thank you.